Industrialized Building System (IBS), also known as prefabricated builds, is a build system in which the construction components are manufactured at factory or at site in controlled conditions. The components are transported and installed as structure with minimum labor. Prefabricated concept is similar to the car assembly industry but differs in terms of component, equipment, and installation method. Among the benefits of IBS use include improvement of construction quality, reduction of labor at site, shorter construction period, as well as a more organized and safer construction site. Principles of IBS core are implemented based on the following four main categories: utilization of IBS components, minimum labor workforce at site, utilization of standardized components based on MS1064, and modular components utilization. Three main components in IBS technology utilizations are structural components, which include columns, beams, floor, and roof trusses; wall component, either panel or concrete block, and other simplified construction solutions; and component based on MS1064, which include the size of the component and repetition method of the building layout. The marking system in IBS core takes into account three main components. A maximum score of 50 points for structural system. Score are given based on the type of IBS usage on building structure. The five IBS systems are precast concrete framing, panel and box system, timber framing system, steel framing system, formwork system, and blockwork system. The two roof systems are timber roof system and metals roof system. Maximum score of 20 points for wall components are calculated based on utilization of either panel or concrete block. IBS wall systems are blockwork systems, precast concrete panels, formwork systems, wall cladding, full height glass panels, and drywall systems. Maximum score of 30 points for the other simplified construction solutions that were applied. A calculation method for standard modular can be divided into two groups. First, the utilization of Malaysian standard MS1064, such as the size of columns, beams, floors, walls, windows, and doors. Second, the repetitive method for building layout. Utilization of IBS core system enables the measurement and assessment of IBS usage level for a building or building projects. Part 1 of the IBS calculation considers the structural system supply. The contractor utilizes a reusable formwork system for all of its structural system, resulting in 23.75 points. The contractor also utilizes roof truss using prefabricated steel, giving a further 2.5 points. This adds up the point for Part 1 to 26.25. Next, Part 2 of the IBS calculation considers the wall system supplied. The internal wall uses precast blockwork system, resulting in 6.9 points, while the external wall of the building utilizes reusable formwork system, giving a further 3.1 points. This adds up the point for Part 2 to 10. And finally, Part 3 considers other simplified construction solutions that were applied. 4 points are given for 100% usage of door sizes as specified in MS1064 Part 4. Another 4 points for 100% usage of window sizes as specified in MS1064 Part 5. 2 points for 100% usage of precast bathroom units. 1 point for 50% usage of prefabricated staircases, 2 points for 90% usage of repetition of floor-to-floor height, 4 points for 90% usage of modular grid lines, 2 points for 80% usage of vertical repetition of structure, and 6 points for submission using level 2 beam model. These add up to the points for Part 3 to 25. Therefore, the total score of IBS Part 1, Part 2 and Part 3 is 61.25. In conclusion, the IBS score can be calculated by summing up the scores from the three main categories, which are the structural components, wall components, and utilization of IBS components based on Malaysian standard MS 1064.